Hi, hello, welcome to another lesson in Math 2. So we're going to be working on perfect squares and perfect square trinomials today. So let's get started. During this lesson, I will learn how to identify perfect squares and perfect square trinomials. So one of our goals is to identify them, and also understand how to manipulate perfect squares and perfect square trinomials from standard form to their factored form. So we're going to do a little bit of both. Let's get started. Alright, so the first three vocabulary are things that we have already talked about. A quadratic, which hopefully you are getting much more comfortable with, is a polynomial with degree 2. A binomial is a polynomial with 2 terms. And a trinomial is a polynomial with 3 terms. Here's the new one. A perfect square trinomial. It's a trinomial in which 2 terms are positive perfect squares, and the third term is the square root of each of those terms multiplied together and doubled. I'm going to take a minute. I'm going to read that one more time. A trinomial in which 2 terms are positive perfect squares, and the third term is the square root of each of those terms multiplied together and doubled. Alright, so standard and factored form of perfect squares. Okay, so these are some algebra tiles. If you came to class meetings, we use those every now and again in class. So it's a completed square. Means if I use these algebra tiles, notice that it is balanced out. I have 2 things on both sides. Just a quick thing of how these algebra tile works is these are all area. This green distance right here is x by x, right? So that means that the total area is x squared. Well, we know already that this line right here down this side is x. Ooh, let's change colors there. I have x by 1. So each of these rectangles are an x. And these yellow ones are 1 by 1. So the area of each of these are 1. I'm going to clean some of this up a little bit. Okay, so if I look at this total diagram, I have an x plus 2 is the length on that side, that upper side, and then if I come down the left here, x plus 2 would be like my width. And so when I find the area, I would say, well, how many x squareds do I have? I have 1 of them in the green. I have 1, 2, 3, 4 x's, and I have 1, 2, 3, 4 of the yellows. So right here would be my standard form of the quadratic, okay? And if I wanted to have the factored form, I would just say my length times my width. So x plus 2 times be x plus 2 here. Okay. So here we go. Here's my factored form right here of f of x equals x plus 2 squared, and my standard form of f of x equals x squared plus 4x plus 4. And it shows off to the side here. Kind of what we just talked about. I have an x plus 2 and x plus 2, and those when distributed out gets me to my standard form. Okay. Now let's talk about what constant terms make each quadratic a perfect square. So how do I figure out that I have a perfect square if I have some stuff missing? So to solve these problems, we have a couple things. First, we're going to take the coefficient of the x term. So that's the number in front of the x term. So in the first one, it's 4. So there's the first thing. Then we're going to divide it by 2. So I'm going to take 4, divide it by 2. There's step 2 right there. 4 divided by 2 is 2, right? Then I'm going to take that 2 and square it. Here's step 3, and we get 4. That is what I would do to get to my constant, okay? So when we divide it by 2, we're getting that number that's in the parentheses. So if I wanted to factor this, I'm going to clear some of this up. if I wanted to see what the factored form of that first one is, it's going to be x, and then whatever we got when we divided this coefficient by 2. So that's a positive 2. So I'd say x plus 2 squared. Okay, let's do the next one. So 6. I'm going to do this one right here. So 6 I divide by 2. 6 divided by 2 is 3. 3 squared. That gives me 9. Perfect. Then, if I wanted to say what the factored form was, I would say x plus 3 squared. Okay, my next one, 8 divided by 2 is 4. 4 squared is 16, which is also my factored form. I'd say x plus 4 squared. Move on to this next one, 12x. I take half of 12, which is 6. 6 squared gives me 36. That's the same as saying x plus 6 squared. Okay, notice something here though. All my a values are 1. So this only works when my a's are 1. Okay, I want you to be able to find the constant for each quadratic. So pause the video, find what that constant would be if these were all perfect squares. Alright, so let's see. So I'd take 16 divided by 2. I get 8. 8 squared gives me 64. This would have to be a positive 64. Next, I would have plus 10. So 10 divided by 2 equals 5. 5 squared gives me 25. Okay, 14 divided by 2 is 7. Oh. We then take 7 squared, and we get 49. Okay, underneath I'm going to write down what my factors would be. I'd get x plus 8 squared. Here I'd get x plus 5 squared. And here I'd say x plus 7 squared. Now, let's say I had something like this. X squared plus 8x plus 16. Okay, we know that this is a perfect square because if I take 8 divided by 2, I get 4. Right? 8 divided by 4, or 8 divided by 2 equals 4. And I square that, and I get 16. I know this is a perfect square. And I wanted to say this is a negative. So I would get negative 4 here. 8 divided by 2 is negative 4. When I factored this, I'd say x minus 4 squared. So if this number right here is a negative, I'll have a negative in my factored form. Alright, so we want to be able to identify if these are perfect squares. So let's take this. I say 20 divided by 2 is 10. 10 squared equals 100. Boom, perfect square. Same thing here. 30 divided by 2 is 15. 15 squared, I believe, is 225. Nope, not a perfect square. 6 divided by 2 is 3. 3 squared equals 9. Nope, not a perfect square. So it's very simple. To find that perfect square, you just have to remember to take that coefficient of the x term, divide it by 2, and that will be how you find your perfect square constant. Okay. Perfect square trinomials when a does not equal 1. So this is when I have a number in front of the x squared term. So here are the things that are important. So 2 of the terms must be positive perfect squares. It's going to be your ax squared term and your c term. So typically your first and your last term are positive perfect squares. The third term, your bx term, is the square root of this of the squares multiplied together and doubled. Okay, so that means that if I take, well, we'll look at it more time. So this term can be positive or negative. Let's look at an example. Okay, so 16x squared plus something plus 25. What is this middle term? That's what we're going to find out. So what I'm going to do is I'm going to take each of these, 16x squared and 25, and I'm going to take the square root of both of these, okay? Now when I do that, the square root of 16 is 4, and the square root of x squared is x. Then I have the square root of 25, we get 5. So what I'm going to do is I'm going to take and I'm going to multiply these together and then double them. So 2 times 4x times 5 gives me 20x. And then 2 times 20x gives me 40x. That's what would have to be right here for this to be a perfect square trinomial. Now, when I factor this, it's going to be whatever I got here and whatever I got here. And then depending on if this is positive or negative, that's what's going to be in the middle, if it's plus or minus. And then I would square it. That would be my factored form of that. So remember, those two things mean the exact same thing. One's just expanded out and one's condensed down. Okay, I want you to try this next one. So pause the video, give it a try. 4x squared plus some number plus 36. All right, here we go. Let's try it out. So I'm going to take 4x and 36. I'm going to take the square root of each of these. Square root of 4x squared, is 2x. Square root of 36 is 6. So now I'm going to take 2x, multiply it by 6, and then double it. So I get 2 times 2x plus 6 is 12x. 2 times 12x is 24x. That's what would have to be here. My factored form of this is going to be 2x plus 6 squared. And I'm going to just write that out without those arrows. There's my factored form. Alright, if you have any questions about this video or this lesson, please come talk to me. Please come talk to a tutor, and we'd be happy to help you. Hope you have a great day. Thanks.